Want to use your own custom data structures with DSPy signatures instead of just basic Python types? You'll see how to define two signature patterns. First, using a standalone query result Pydantic model with text and score fields, then using nested classes inside myContainer to group related input and output types. The code shows exactly how to reference these custom types in your DSPy signatures.
Hash simple custom type. Class query result Pydantic base model. Text SDR. Score float. Signature equals DSPy signature query SDR result query result. Class myContainer. Class query Pydantic base model. Text SDR. Class score Pydantic base model. Score float. Signature equals DSPy signature query myContainer query score myContainer score.
This demonstrates custom type composition in DSPy signatures, where Pydantic models define structured schemas for input and output fields. The code shows two approaches: a standalone query result model combining primitive types, and a container class, myContainer, that organizes related models under a shared namespace. The key pattern is using Python's native class system to create reusable type definitions that signatures can reference. The approach works by declaring these custom types directly in signature strings, where field names become the interface contract. When a signature specifies result, query result, or query, myContainer, query, it leverages the underlying Pydantic models to define the expected data structure. This creates a clean separation between the type definition in Python classes and the behavior declaration in signatures, without embedding schema logic inside the signature itself. This pattern matters because it enables modular type reuse across multiple signatures. The container class example shows how to logically group related types, which becomes particularly valuable as the number of signatures grows. The trade-off is the initial modeling effort, but it eliminates redundant type definitions and makes the expected data structure explicit through standard Python type hints. Let's break it down line by line.
Hash simple custom type. Class query result Pydantic base model.
This defines a query result class inheriting from Pydantic base model, enabling structured data validation. The base class provides the foundation for type enforcement that will be used in the signature definition.
Signature equals DSPy signature query SDR result query result.
This defines a DSPy signature that maps a string input named query to a structured query result output. It establishes the type contract for this specific operation using the previously defined Pydantic model.
Class myContainer.
Declares a myContainer class to namespace the nested Pydantic models that follow. This is a basic class definition that will contain the query and score model classes, grouping related data structures together.
Class query Pydantic base model.
Defines a nested query class inheriting from Pydantic base model, creating a typed data structure. This establishes the input schema that will be referenced in the signature definition.
Class score Pydantic base model.
This defines a nested score class that inherits from Pydantic base model, creating a typed data structure. It mirrors the pattern used for query, establishing consistent model definitions for the DSPy signature.
Signature equals DSPy signature query myContainer query score myContainer score.
This defines a DSPy signature using the nested Pydantic models myContainer, query, and myContainer score as type annotations. It declares that the function will accept a query object and return a score object, mirroring the structure defined in the container class. DSPy custom type definition. The code demonstrates two ways to define typed signatures, using standalone Pydantic models like query result with text and score fields, and using container classes like myContainer that group related models, query, score under a single namespace. Dot notation in signatures, myContainer, query, directly references these nested classes, maintaining clean organization. All custom types must inherit from Pydantic, base model to work in DSPy signatures.
The container that divides its contents unifies the type.